Good morning, students. Today we are going to do action of sodium hydroxide solution and ammonium hydroxide solution on solutions of certain salts. Let us take a look at the reactions. With you are using sodium hydroxide solution as the alkali. You choose a salt that contains calcium ion. For instance, calcium nitrate solution, which is white in color. You add dropwise sodium hydroxide to calcium nitrate. What do you see? You observe a clear solution is formed, which is sodium nitrate, and you'll see an insoluble precipitate has formed, which is white in color, that is calcium hydroxide. This is insoluble in nature or very sparingly soluble. No matter how much of sodium hydroxide you add to it, it doesn't go into solution. Next, let's take magnesium chloride solution, which is white in color. You are adding in small quantities first sodium hydroxide. You see magnesium hydroxide is formed, which is dull white in color. The precipitate is magnesium hydroxide. What is the nature of the precipitate? It is insoluble. That means even if you take excess of the alkali sodium hydroxide, magnesium hydroxide doesn't dissolve in it. Next, let us take a look at ferrous ions. So we choose a salt, for instance, ferrous sulphate, which is green in color. When you add dropwise sodium hydroxide to ferrous sulphate solution, you see dirty green precipitate of ferrous hydroxide, which is insoluble in nature. So that means even if you add excess of sodium hydroxide to ferrous hydroxide, it does not dissolve. And what is the color of the precipitate? Dirty green. Similarly, ferric chloride solution, when reacted with sodium hydroxide solution, gives you sodium chloride solution, which is the clear solution, and a precipitate of ferric hydroxide, which is reddish brown in color. And what is the nature of the precipitate? It is insoluble. That means even if you take excess of sodium hydroxide, ferric hydroxide is not going to dissolve in it, hence it is insoluble. Now cupric ions. So we've chosen copper sulfate as the solution. Okay, copper sulfate is blue in color. We are adding to it dropwise sodium hydroxide solution. What do you see? A clear solution of sodium sulfate, and you'll see a pale blue precipitate of copper hydroxide. Now, what is the nature of this precipitate? It is insoluble in nature. Now, with reference to zinc ions, we've chosen a salt which is zinc sulfate, which is white in color. When you add in small quantities sodium hydroxide solution to zinc sulfate, you'll see zinc hydroxide is forming, which is a white colored gelatinous white precipitate. Now what happens when you add excess of sodium hydroxide to this precipitate zinc hydroxide? Look at the reaction. Zinc hydroxide plus sodium hydroxide in excess gives you water and sodium zincate. That means it is soluble in excess of sodium hydroxide. Are you with me? So earlier it was gelatinous white, now it dissolves in excess of sodium hydroxide to give a colorless solution. Finally, lead salts, and this is lead nitrate solution, which is white in color. You adding to it sodium hydroxide in small quantity, then you see lead hydroxide is forming, which is a chalky white precipitate. This precipitate on adding excess of sodium hydroxide, what happens? It dissolves in it. Okay, so we say it is soluble in nature. Are you with me? So you have to learn the equation, and then the color of the precipitate and the nature of the precipitate. Before moving on to ammonium hydroxide, please see that you write correctly balanced equations: color of the precipitate and the nature of the precipitate. Now let us take a look at reaction with ammonium hydroxide solution. Now you have studied using sodium hydroxide solution. Now let us switch over to ammonium hydroxide. So in any case, you are going to get a precipitate in the form of metal hydroxide and a solution that is clear. Okay, now what you're going to give emphasis on: the color of the precipitate and the nature of the precipitate, meaning whether it is soluble in excess or not. So first one is calcium salt, which is calcium nitrate. No precipitate of calcium hydroxide is formed. Okay, that means it does not give a visible reaction because concentration of hydroxyl ions is low and cannot form precipitate of calcium hydroxide. This is the reason. Now, let us take a look at magnesium chloride. Magnesium chloride, when you react with ammonium hydroxide solution in small quantity, you get a clear solution of ammonium chloride, and you'll see a dull white precipitate of magnesium chloride. It is insoluble. That means even if you take excess of the alkali, it does not dissolve. So it is insoluble in nature. Next, ferrous ions. So we've taken ferrous sulphate solution. You are adding to it in small quantities ammonium hydroxide. You see that a dirty green precipitate of ferrous hydroxide is forming. Okay, and what is the nature of the precipitate? It is insoluble. No matter how much you take ammonium hydroxide, ferrous hydroxide is not going to dissolve in it. Similarly, ferric ions. So we've taken a salt solution containing ferric ions, which is ferric chloride, okay, or we say iron 3 chloride. When reacted with ammonium hydroxide solution in insufficient quantity, you get ammonium chloride solution and you get a reddish brown precipitate of ferric hydroxide. Now this precipitate is also insoluble. Okay. Similarly, cupric ions. So we've taken copper sulfate solution. Copper sulfate, when reacted with ammonium hydroxide solution, it gives you ammonium sulfate and a precipitate which is pale blue in color, and that is copper hydroxide. This is pale blue in color. Now what happens is, if I add excess of what? Alkali, ammonium hydroxide, what do I get? I get a complex salt solution which is tetramine copper sulfate. Okay, that is CuNH3 bracket 4 SO4. Now this compound, now earlier it was pale blue, and now when you react in excess, you'll see it turns inky blue, or you say deep blue in color. That means it is soluble in excess of ammonium hydroxide, which is it finally turns into a deep blue solution. Now then we move on to zinc ions. We've taken a salt which contains zinc ions, for instance zinc sulfate. When you react with ammonium hydroxide solution, you get ammonium sulfate plus zinc hydroxide. Now zinc hydroxide is a gelatinous white precipitate. Okay, it is gelatinous white precipitate, and this salt is soluble in excess of ammonium hydroxide. oxide. So when I add excess of ammonium hydroxide, I get a complex salt, okay, and uh, it turns into a colorless solution, and that is complex salt of tetraamine zinc hydroxide. And the last one is the presence of lead ions. The salt is lead nitrate solution, which is colorless. You add to it in small quantities ammonium hydroxide. What do you observe? You observe a precipitate of lead hydroxide, which is chalky white, just like your chalk. And when you add excess of ammonium hydroxide to the precipitate lead hydroxide, you will see that it does not dissolve. So we say it is insoluble. Look here. Identification of cations means positively charged ions. Addition of ammonium hydroxide solution to the given salt solution. Now, actually, when you are performing the experiment in the laboratory, what do you see? When you add in small quantity ammonium hydroxide to ferrous salt, maybe ferrous sulphate, okay, this is what you see. You see a dirty green precipitate. Dirty green precipitate. And what do you see? What do you observe when you add in excess of the alkali? You see that it does not dissolve. So we say in excess it is insoluble. Now let us take a look at ferric ions. Let's say you've taken ferric chloride solution, okay, and initially you have added in small quantity solution of ammonium hydroxide. What do you observe? You have seen that in the test tube its reddish brown precipitate has formed. Reddish brown precipitate. Now I add excess of ammonium hydroxide. What do you observe? It does not dissolve, so it is insoluble. Are you with me? So when you actually conduct the experiment, that time you'll see the true color and it will remain in your mind forever. Now suppose you have taken copper sulfate solution. So the cation is cupric ions, okay. When you add in small quantity ammonium hydroxide solution, what do you observe? Pale blue precipitate. Now what do? I add excess of, look here, I add excess of ammonium hydroxide to this. What do you see? In excess, soluble, deep blue solution is formed. Deep blue solution, more like your blue ink. This shows that it is soluble in excess of the alkali ammonium hydroxide. Are you with me? Next, let us take a test for calcium ions. Initially, you are adding in small quantity ammonium hydroxide to any calcium salt. There is no precipitation taking place. I just told you the reason a little while ago. In excess also, there is no precipitation taking place. So you can say that no visible reaction take place. Are you with me? Now let us move on to zinc ions. I have taken, let's say, zinc nitrate solution. So it contains which ions? Zinc ions. In small quantity, I am adding to it ammonium hydroxide. What do I observe? Gelatinous white precipitate. What is the nature of the precipitate? When I add excess of ammonium hydroxide to the precipitate, in excess it is soluble. Is that clear? Now, let us see lead ions. Suppose you have taken lead nitrate solution in this test tube and you have added in small amounts, okay, the alkali ammonium hydroxide. What do you observe? Chalky white precipitate. And what happens when you add excess of the alkali ammonium hydroxide to it? In excess, it is insoluble. That means it does not dissolve even in excess of the alkali ammonium hydroxide. This brings us to the end of today's lesson. I hope you have understood the concept, and the main concept is you got to know the color of the precipitate and the nature of the precipitate. Thank you.